Alright, let's begin this lesson with a little bit of a review. We are going to review writing equations in slope-intercept form. Y equals mx plus b, where m is the rate, how much it's going up per something or down per something, and b is the beginning point. So in other words, the m is the slope, which is the same thing as rate, and b is the y-intercept of the beginning point or the starting point. So if we're going to write an equation for each situation, so Sally's segues, we're trying to go from one location to another location. We're trying to figure out, should we rent a Segway or a bike? So we're going to look at the situation. Sally's Segway charges a $20 deposit. So that's the upfront cost, and $10 an hour. This is the per cost. So that is the rate. So that would be Y, or C for cost. I'm just going to use Y and X. $20 up front plus 10 per hour. So X is the number of hours. And Y is the total cost. Okay, and I know that it's not, these two are switched. The M and the MX and the B are switched around, and it doesn't matter because of the commutative property with that addition. I like, when I'm talking about application problems, to put them in the order that I think about it. I would think about it as 20 up front plus 10 for each hour. Alright, so Bert's bikes, his total cost is $10 up front plus 20 an hour. So if we're going to compare this like we've done in past units, we can see that Sally's Segways start at a higher upfront cost but goes up at a slower rate than Bert's bikes. Bert's bikes starts at a lower upfront but goes up more for each hour. This is what we can call a system of equations. And you don't have to write this down at this time. I just want you to know a system of equations is just one or two or more options about the same situation. And it allows us to make informed decisions. Sometimes we actually know what the situation is. Like in this case, we're trying to figure out what would be the cheapest way to travel. Sometimes we don't. They just give us the equations. But we're going to be looking at over the next 16, 17, 18 days how to solve a system of equations like this. So today, while it is the intro to systems, we're going to really be looking at solving problems using tables and graphs as a way to introduce you to what a system looks like and what we can do with it. Alright, so hopefully you have your sheet in front of you. This is the first example that we're going to do together. Your teacher has decided to give rewards to students completing their assignments in forms of M&Ms. Here are three choices, and you have to decide which is the best choice. So choice 1, you get 12 M&Ms up front plus 3 per assignment. Choice 2, you get 6 up front plus 6 for every assignment you have completed. And choice 3, you get 0 up front but 12 for each assignment. So depending on your work ethic and how much you do, you might choose a different choice. So our first task is to write an equation, and we know this. We know that how much we get up front, that is our b, and y equals mx plus b. And the per assignment, that's our rate or our slope, so that's the m. So here I have y, which is the total number of M&Ms, equals how much I start with, plus how much I get per assignment. So choice 1, I start with 12, and I add to that 3 for every assignment that I complete. We could have also written this in the actual y equals mx plus b, where the x term comes first. Either of these is correct, as long as you realize that 3 is your rate and 12 is your y-intercept. So choice 2, we get 6 up front plus 6 more for every assignment. In choice 3, we get 0 up front, so I'm not going to put that because it doesn't change the equation, but we get a whopping 12 M&Ms for every assignment that we complete. So the next set of directions is to figure out how many M&Ms you would give for each of the choices, given the equations we just wrote. So which option should we choose and why? So once we fill out this table, we should be able to see a pattern to choose and justify our reasoning. So choice 1, we could start this in a couple different ways, or complete the table in a couple different ways. We could put in, for one assignment, remember this is our x, 12 plus 3 times 1 is 15. And now our x is 2, so 12 plus 3 times 2. So 12 plus 6 is 18, etc., etc. But I'm hoping you remember that this tells us how much the y is going up. So after you get this, you can just add 3 every time. So another assignment, another 3 M&Ms, another assignment, another 3 M&Ms, etc., etc. And the reason we didn't start at 12, we started on our table at 15, and that's because, remember, our starting point is what y is when x is 0, and this we started with 1. So we had to add in the 3 up front. All right, so choice 2. Here we have 6 up front plus 6 for every assignment. So after one assignment, we have 12. After 2 assignments, we have 18. And then I'm hoping you remember you can add 6 because our rate per is 6. So we can add 6 every time. So we have 24, 30, 36. And the last choice, we don't get any up front. So it's just 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. And again, we're going up 12 every time because that is our rate. And the next part really is, you could justify what option you should choose and why many different ways. If you're a slacker that doesn't do any assignments, then you will probably want choice 1 because at least you're getting some up front. If you are someone that sometimes does their assignment and sometimes not, you might choose choice 2 because at least you get something up front and you are getting something per. But for those of you that are really intrinsically motivated and you do your assignment every single time, you definitely want to choose choice 3 because look, here choice 2 and 3 are the same after one assignment. Choice 2 and 1 are the same after 2 assignments, but choice 3 has already jumped ahead by 6 M&Ms. So here it's showing you there's a huge advantage to choosing choice 3 and getting your assignments in. All right, let's look at one more example. This is about Fred and Wilma washing dishes. It says Fred washes 3 dishes per minute. So Fred's rate, his rate is 3 per minute. So his M is 3 per minute. Wilma washes 5 dishes per minute. So her rate is 5 per minute. Fred has already washed 6 dishes when Wilma starts. So Fred, when they start washing together, he already has 6 dishes done, where Wilma has just started. So Fred is going up 3. So after 1 minute, he's washed 3 more dishes, which is 9. And another 3 minutes, another minute is 3 more dishes. So he is going up 3 every time. 21. So his equation, his number of dishes, he started at 6 and he went up 3 for every minute. Where Wilma, she has 0 when they when it first started, but she's going up 5 for every minute. So 5, 10, 15, 20, 25. So her number of dishes, starting at 0, which we don't have to put, but she's going up 5 for every minute. All right, and this is where you will see how you could solve the equation, the system of equations using a graph. So here we know x is our number of minutes, and our y is the number of dishes. All right, so the way I have my graph set up, it's going to be a little tricky to graph Fred's because the numbers don't work nice and easy, so we're going to have to estimate a little bit. So here I'm going to put a point at 6 because his y-intercept where he begins is 6, and then he goes up 3 for every one set of dishes. So I have mine numbered where it's 2.5, 5, 7.5, 10. So I have to think, okay, if I go up 3, that's 8, so it's a little bit before 10. So I'm going up 3. And I can also use the table. So Fred's, oops, I did a little curve. And again, it's going to be really important for you to use a straight edge. Where Wilma's is easier. Starts way down here, and I'm going to use red. At 0, she doesn't have a beginning, but she goes up 5 for every one. Up 5 for every one. Up 5 for every one. So hers looks like this. And again, I'm not using a straight edge, so it's not exact. But we'll find out a way to find the exact point without having to graph. So to describe the graph, and I'm not going to write it all right here because my stylus is breaking, I will admit that. But what I want you to be able to explain is that Fred starts higher but goes up at a slower rate. So he starts doing more dishes but ends up after time, like 2.5, 3, somewhere in here, he ends up making less dishes. Cleaning less dishes than Wilma. Wilma starts out with less, but she's going up at a faster rate. So what we're looking for is that ordered pair that makes both true. So right now, just estimating, it's like 2.5, 12.5, somewhere in there, where they're exact. But we can find the exact point if we graphed this very carefully, and some of you might have already done that.